Alright, this is 22.2, solving equations by completing the square. And you've seen this model before, right? All the dark ones are negatives. We got 1x, x squared, negative 1, negative x squared. And what they've done is they've created a equation here that is, we've got x here and 3x's over here. We got an x here and 3x's over here, right? For a total of x squared, and we can say 3x and 3x is 6x. I'm going to write it down here, x squared plus 6x. And if you fill in these spots created by those x's to complete a square, we could see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 ones that would have to be added. So, representing the completed square, it's x squared plus 6x plus 9, right? X squared plus 6x plus 9, x squared plus 6x plus 9, and what they want to know is what binomial creates that. Well, it's x plus 3x, right? X plus 3x. Oh, I take that back. X plus 3 squared. That's what that is. So these are the 3 x's in here, but we'll keep going here. So refer to the algebra tile in the diagram and write the expression created by this. So let's look. We've got x, x, and it looks like 1, 2 there, and x, x, and 1, 2 here, and that gives us 4x squareds, right? We got 2, 4, 6, 8 x's, and if I fill in this spot right here, it's just 4, so plus 4. So I want you to notice something in this equation right here. In order to get this 9, what we did is we split the 6 in half, right? We split this 3 and 3, so we took the middle number, right, that we see in here, we split it in half, and then we squared it, right? Can you see that happening? 3 of them went over here, 3 of them went over here, so that 6 got split to half, and when you multiply those together, that's what gave us 9. So it was the half of the 6 multiplied together that gave us 9. Come down here, you can see that. Now I've written this on the other side, we're okay. Alright, so when you come over here, what we just talked about there was taking that 6, dividing it in half, and squaring it to get our 9. That's how that number 3 relates to the total number of x tiles. And if we did that in terms of this guy right here, what that really is, it's the b term divided in half squared. Whatever the one in the middle. Remember, if I have ax squared plus bx, it's this term divided in half squared is what is equal to c to create a perfect square. So what if I was going to find out this c right here? Well, my b term's 8, right? So it's that 8 divided in half squared, which would make it 16. So c in this case would be 16 if I wanted to make a perfect square. I'm going to keep going right here with that rule, half of b squared. And this works when your leading coefficient is 1. Right? So when I go here, I can see that this, we've got x squared plus 4x. So what I do is I take my b term of 4, right? We take 4, divide it in 2, and square it, and we add 4 to complete it. Let's keep going. See this guy right here? Look at this one. This got a negative 8, so my b term's negative 8. I'm going to do the same thing. Half of that squared. Half of negative 8 squared is the same as negative 4 squared, which is 16. So to complete the square, I'd put 16 there. Notice this b is negative. This says, hey, why in the world do we still get a positive number? Well, the truth is, negative 4 squared gives me a positive number. So when we square, doesn't matter what b is, once you square it, that negative goes away. Let's complete this guy right here. There's my b term. Think about what you do. You take that 12, think it in your head before I say it, divide it in half, and square it, and we get 36. And then we have a perfect square. I'm gonna stop here, but I want to show you how that factors one more time. It's very important to know how to factor perfect squares. You take the square root of this, you take this sign, you take square root of that, and then say that quantity, the whole thing squared. Alright, so we are going to solve by completing the square next, and we'll talk to you soon.